Hello everyone. In this video, I'm going to show you how to apply weight to enhance data set in SPSS. Now, enhance is the National Health Interview Survey data, which is a national population-based data set. Now, if you are using enhanced data set, a data set which is a national a population-based data, it is important to actually apply weighting to your data set. Now, some of the importance of doing that is to help minimize sampling error and also a potential type 1 error in your analysis. So it is very important whenever you are performing analysis using a national population-based data set, you apply some weighting. So this video is actually going to help you and direct you on the weighting process for the enhanced data in SPSS. Now, to do so in this video, you are going to be able to learn three things. It is how to correctly apply the sample weight to the enhanced data, and then also the variables that you need to actually select to in order to correctly apply this weight to your sample or your data set, and then also what are the functions or tools in SPSS that I have to use to be able to actually perform this weighting process. So in order to do that, first of all, let us look at what are the variables that are for the weighting process in NHIS. Now, once NHIS, they collect their data, there are three variables or items that are actually used for the weighting process, which is the first one is the strata, which in other is the stratum, which is for the sample estimation of the sample variation, that is the variation estimation. And then also we have the primary sample unit, which is also for the sample variation. And then the third item is the sample person weight, which in NHIS, it is being represented by some weight. So these are the three major variables you are actually going to look at to be able to apply the weighting process. So if you look at your SPSS variable names, you are actually going to see these variables, which is being represented by this abbreviation, which is strata, PSU, and then sample weight. So next, what tool are you going to use in SPSS to be able to perform this analysis? The familiar tool which we know in SPSS for sure for most of analysis in SPSS is what we call the analyze. Now, once you have click on analyze, there is going to be a function which is called the complex samples. Then once you select the complex sample, there's another tool you would have to select, which is also known as the prepare for analysis. So these are the three most important tools, or in other words, functions that you're actually going to select in SPSS to be able to start the weighting process. So without much time I waste, let us get onto SPSS and then practically perform this weighting process. Okay, so now the data we are going to use for this process is 2019 to 2022, that's 2019 to 2022, and his data set, which we are actually going to use in performing this weighting process. Now, if you have been able to collect your data from NHIS, wherever you are able to obtain your NHIS data, once you have your data, you have, if you look at the variable view of your SPSS, you're actually going to see some of this information. And part of the information you have to be able to collect is the three weighting items, which I made mention of, which over here we have the strata, we have the PSU, And then we have the sum weight here, which we have it here. So these are the three items you have to be able to make sure you collect it in addition to your NHIS data set. Most often, if you use a database like the IPOMS in collecting your NHIS data set, by default, once you have extracted the data, they add these items to your data to be able to actually perform the weighting during your analysis. So now, how do I how are you able to apply the weighting? So once you have your data, so there's my data, I have my data here. So I go to analyze, and then I go to complex samples. Then I go to prepare for analysis. So once I click on prepare for analysis, now we are going to create what is called the analysis plan, complex analysis plan, which once we are able to create a complex sample analysis plan, we are going to use this complex sample analysis plan to be able to actually perform our analysis and apply the weight whenever it's needed. So once you have selected this, you have this pop-up window. Now you have to be able to, first of all, before you click on next, you have to be able to create a location where you would want your analysis plan to actually be. So for instance, I have on my desktop, I have this information, which is NHIS weight. That's where I want my analysis plan to be. So I'm going to name it, let's say, CS, that's complex sample, CS analysis plan. Let's see, that's what I want to name it. Okay, so now you go to save. So now you have save. So now you go to next. Now next here, you are now coming to select the variables or the items, which is the three variables or the item I made mention of. So now you go to, let's use display names to be able to know the variable. So we have, first of all, we have the structure. So you have to select the structure here. And then we have the cluster. The cluster represents the PSU, which is the primary sample unit. And then we have the sample weight, which is the sample weight. Now you go to next. And then here you have to uncheck the use finite population correction. You have to uncheck that. And then remember over here we have the WR, which is sampling with replacement, which make the data random sampling, which is very important. Then also we go to next. Now, once we have gone to next, you are going to be able to see how, let's see. So once you have gone to next, you just have to, this information, oops, let me go back and come back again. So next. So now at this point, you are able to actually view the information that have actually, the tasks you have already performed. So we have the strata, we have the cluster, which is the primary sample unit, and then we have the sample weight, and then also we have the, which is the sampling, the method, which is sampling with replacement. And then there's the pathway where your complex analysis plan is going to be what? It's going to be saved. So now we can go to next, and then now you can actually copy and then paste your into a syntax. You can copy and generate a syntax where you can actually be able to run the syntax and then start the process of actually applying your weight. So now I go to, okay, finish. Now here the syntax. So now you can actually Next, you can select all. You can select everything here, and then you run the syntax. So once you have run the syntax, you have this information. So now, which means our complex sampling plan or weight have been actually generated, and then it's ready to use. So now, in order to apply it, for instance, let's first of all perform some descriptive frequency in a particular variable. Let's say descriptive frequency for region of the individual, and let's say the sex of the individual. And then maybe let's look at maybe the citizenship status of the individual. So this is what we have without the what? Without the weight, right? So this is what we have without the weight. So now let us look at how am I going to apply the weight to my frequency percentages to be able to have percentages for my data, which actually include the complex sampling weight I just created. So in order to do that, you go to analyze, and then you go to the complex samples again. Then you select frequencies. So once you select frequencies, so now it is now asking you can now browse to actually find the location where your weighting is. But if you already did it rightly, it actually gives you the pathway. Once you have the path, you then click continue. So once you have clicked continue, now let us look at performing frequency for these three variables, which is region, sex, and then let's say regions of the individual, sex of the individual, and then let's say the citizenship status of the individual. Now you can click here, and by default, SPSS check this one, which is the population size. And then usually you may not want the population size, but you would want to know the table percentages and then maybe the unweighted count. And then if you need the standard error of each percentages, you can have it as well. And if you need a confidence interval for each of the percentages of the sample categories, you can have it. But in the meantime, let us look at the table percentage and then that of the unweighted count. So you can just go to continue, and then let's say, okay. Let us look at how different it is. Now, for instance, if you look at the region of residence, you can see that the counts are the same, right? So you can see we have the counts of the region of residence, which is the unweighted count versus the frequency, which did not apply the weighting the same. But let's look at, here is what it matters most, the percentages. Now you can see we have different percentages. So this percentage here is the one which we apply the weight. And this percentage you are seeing here is the unweighted percentage. So more often it's very important to make use of the weighted percentage. Again, that is the percentage in which we are sure that there is a minimization of sampling error and a possible type 1 error, particularly if you are performing inferences. Okay, so you can see again for sex, you can see the unweighted percentage is here, the sample, the frequency is here, the frequency and then the unweighted count are the same, but the percentages for the weighted percentage, we have 48.4% for males, but the unweighted percentage is 45.7%, which is a huge difference of about almost about 3% different. And then you can look at also for the females, and then that's for the females. Now, again, there are also other analysis in which you can perform as well. So for instance, if you want to perform, let's say, a chi-square test, you have to go to cross tabulation and then go to continue. So let's say I want to perform a chi-square test of, let me use the names. Let's say this variable, which is a dementia variable. So let's say I want to perform a chi-square test to assess whether there is a differences for sex in terms of having dementia or not having dementia. So for instance, that's Alzheimer's disease you might think of. So I can select sex, and probably say I can select, let's say another variable, let's say merit. Let me choose a different variable, probably let's say the region of the person. So I want to assess whether sex and the region of the person, there's a statistical significant difference in the levels when it comes to having Alzheimer's disease or not. That's for dementia. So you go to statistics, and then with the statistics, I don't want to see the sample percentages, but let's say I want to see the table percentages, let's say the column percentages, and then probably I also want to see the unweighted counts for each of them. So I can just, so there is also other things you can actually assess here, which is the odd ratio, the risk difference, the relative risks. So either any of them I don't need, but I want to perform the chi-square test, which is going to test the test of independence between the rows and the column. That's in other words, it's going to be able to test for me to be able to know whether there's a relationship between Alzheimer's and then the independent variable I selected, which is sex and the region of the individual. So I select that and then I go to OK. So here is what you have. So for instance, I have individual having no Alzheimer's, yes, Alzheimer's disease. And then for males, I'm able to know what percentage of males reported having an Alzheimer's disease with the standard error, which is given, which is 44%. For females, what percentage of females have reported having Alzheimer's disease, which is about 55.1%. Yeah. And then also, when I go to the region, you can see Northeast, North Central or Midwest, Southwest, and then also their corresponding, those that correspond to individual not having Alzheimer's and those having Alzheimer's. So we are able to know the percentages for individuals that are having Alzheimer's given their regions. And then here's a statistical test, which is the chi-square test, which again, we have the p-value, for instance, we have the chi-square test for sex and those, whether the individual have dementia or Alzheimer's disease, which is 0.033, which is statistically significant. It means there is a significant difference between having Alzheimer's disease or not when it comes to an individual, when it comes to the sex variable. And similarly, if you look at the regions of residence, there is also a statistical difference for having Alzheimer's disease or not. So in other words, there's a relationship between sex and then Alzheimer's disease, and then also there's a statistically significant relationship between region of residence and then also Alzheimer's disease. Now, next, you may also want to perform logistic regression, right, to be able to know whether there is association, for instance, between sex and then having an Alzheimer's disease, right? So you can select this particular, again, you go to, once you go to analyze, you go to complex samples, you can now go to logistic regression, and then you click on it, you go to continue. So in your logistic regression, you can select your independent, your dependent variable, which the dependent variable, for instance, we say the dementia or Alzheimer's disease, and then we can select our factors. So let's say the factors, we say the sex of the individual, let's say the region of the individual. And then maybe you might want to include covariate, which is age as a covariate, right? And then you can just go ahead. I mean, once you click on the statistics, there are several other tests you might want to perform, but I mean, none of which I would want to perform here. Then you can go to the odd ratio. So you go to the odd ratio, you have to be able to select all the factors and put it into the factors here, and then you put the covariate as covariates. And then you go to continue, and then you might also want to click here to be able to actually tell SPSS which group of your dementia variable or your enzyme variable represent the reference. So once you have selected that, you go to continue. And then also you notice over here that all the highest variable is being used as a reference. So here is where it becomes very important when it comes to you choosing your reference. You have to make sure that for every variable you put in the as a factor, that variable, the highest group of that variable, the category of that variable is the reference, just to be sure. So now once you are done with everything, there is an also option here to actually select and then perform another test. Again, I don't want to do any of them, so I go to okay. So now I'm able to perform the test, and here is the test which have been actually given. So it starts from here. You have the variables given. So this is yes, no, and then you have male, female, you have the region of the individual. And there's a statistical test actually testing for each of the independent variable and then the covariance in the model. You can see region is statistically significant here. And then you can see also age is statistically significant when it comes to Alzheimer's disease. And then you can see you are giving the adjusted odds ratio along with the confidence interval of the odds ratio. And then you can see females are less likely of psychological, less likely of Alzheimer's or dementia compared to males. Then you can also see the region which have been given for each category of the regions. Yeah, each category of the regions is given here, and then you have been given, how do you call it, the selected variables. And then also you have the odd ratio for that of what? For that of age. So that's how you can actually, the data is not actually completely clean, but this is just a demonstration of some of the tests you can actually perform once you have been able to apply your weighting sample. More importantly, through this lesson, you were able to actually know how to be able to apply the weighting when it comes to using NHIS data set. I hope you did enjoy it. Thank you very much.